Welcome to the session number 13 from the playlist of motion in a straight line. The topic for the session is the straight line motion involving the acceleration and the deceleration. So based on this topic, I have selected one question which was asked in the IIT-JEE examination long back in the year 1978, and this question was also asked in the CBSE All India Pre-Medical Test in the year 1994. The question here is, a car is starting from rest and moves at a constant acceleration of alpha for some time. After that, it decelerates at a constant at beta and comes to rest. So the question is, we have to find the maximum velocity of the car if the total time elapses t. So let us assume that the car accelerates for time say t1 and decelerates for time say t2. So now if the total time elapses t, then t will be equal to t1 plus t2. So this is the first equation which I have got. Now in the first part of the journey, the car is accelerating at a constant rate alpha, and in the first part of the journey the car is starting from the rest. So by using the equation of motion for constant acceleration, that is v is equal to u plus at, I will get the maximum velocity attained by the car, because the car is accelerating in the first part of the journey. So the maximum velocity which the car will attain will be at time t1. So the maximum velocity attained by the car will be equal to 0 plus alpha t1. Okay, so this is the equation number 2, and I will be writing this equation here on the top, that is v maximum is equal to alpha t1. This is the equation number 2. Now for the second part of this journey, the maximum velocity which the car has attained in the first part of the journey will become the initial velocity for the second part of the journey. So again, by using the equation of motion for constant acceleration, the initial velocity for the second part of the journey will be equal to the maximum velocity which the car has attained in the first part of the journey. So this will be equal to alpha t1, and the final velocity will be equal to 0. And in the second part of the journey, the car is decelerating at the rate of beta. So this will be equal to minus beta t2, where t2 is the time taken by the car to decelerate from this maximum velocity to 0. So from this equation, I will be getting the value of t2 is equal to alpha t1 divided by beta. Okay, let us say this is the equation number 3. So if I substitute this value of t2 in the equation number, say this is equation number 1, I will be getting this is t is equal to t1 plus t2. I will be getting the value as t is equal to t1 plus t2. We know that t is equal to t1 plus t2, where t is the total time elapsed, and so this will be equal to t1 plus, now t2 is equal to alpha t1 divided by beta, and this is equal to t. So from this equation, if you solve this, what I will be getting is that this will be equal to, I will take the LCM as beta, so this will be equal to t1 in bracket alpha plus beta. So t1 alpha plus beta is equal to beta t. So this is the value which I am getting for t1, and t1 will be equal to beta t divided by alpha plus beta. So the time taken by the car in order to accelerate from 0 to this maximum velocity, or you can say the time for the first part of the journey, that is that part of the journey in which the car has accelerated at a constant rate alpha is equal to beta t divided by alpha plus beta. So the maximum velocity, which is equal to alpha t1, will be equal to alpha beta t divided by alpha plus beta. Because the V maximum is equal to alpha t1, so the value of t1 is beta t divided by alpha plus beta. So the maximum velocity attained by the car will be equal to alpha beta t divided by alpha plus beta. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the same chapter, that is motion in a straight line. So till then, have a nice day. Bye.